Hello, everyone. First, I want to thank the organizers at Heritage Education Network Belize for gathering us for another year of engagement and discussion. The past year, I completed my dissertation on the ceramic economy of the Middle Preclassic Maya, living in the Mopan River Valley, and I'm incredibly honored to present the results for the first time at the Culture Symposium. This project was born out of an interest to better understand the relationship between two sites in the Mopan River Valley during this early period, a time of rapid and significant social, political, and economic change. As you'll see shortly, or are already aware, the sites of Early Xunantunich and San Lorenzo are located just across the river from each other and remain mutually visible to this day. Given their close proximity, I wondered what their relationship was during the early period and how this relationship might be reflected in the material record. Based on a theoretical framework of ritual economy and previous excavations at both sites by SHAP, MVAP, and MVPP, I predicted a slightly uneven relationship between Early Xunantunich and San Lorenzo. I hypothesized that Early Xunantunich, this monumental pre-classic complex, would have been a node of public activity, drawing in residents of surrounding settlements for community-based rituals and gatherings. In this hypothesis, San Lorenzo was one such settlement. These intercommunity events would also have served as the mechanism for circulation of ceramics, with surrounding settlements bringing vessels to the center in participation of these large-scale events. To test this hypothesis, I developed a model that measured these same variables in each assemblage so that I could directly compare them. These markers of production, as I call them, include the paste, form, surface treatment, and firing, representing potters' choices at every stage of ceramic production. These choices, while primarily founded on the knowledge and skill of the potter, are also responsive to the sociopolitical and economic climates in which ceramics are made, distributed, and used. The variables can be seen here on this chart, which plots a hypothesis-based prediction. In other words, if it were true that residents of San Lorenzo contributed to the ceramic record at Early Xunantunich through intercommunity gatherings, the material record would yield higher variability in paste recipes, surface treatments, and other aesthetic elements at the monumental center. In this situation, similarly, lower variability would be present within the San Lorenzo assemblage, which was more likely a result of single or intra-community activity. My work ultimately sought to understand how ceramics were produced and circulated across the Mopan River Valley. Testing these complex relationships that involved the multiple moving parts and influences of ceramic production, distribution, and consumption required an equally complex methodology. This investigation included 4 phases: macroscopic, mineralogical, and chemical analyses, as well as ethnoarchaeological collaboration. These methods are displayed this way because the research design recognizes the ability for each type of analysis to complement and inform the others, creating a holistic understanding of the trends in and across both assemblages. I think that this methodology has intrinsic value outside of the model I designed for this project, as it captures data from every stage of ceramic production, from the procurement of raw material to the firing techniques and aesthetic choices of potters. Unfortunately, I don't have time to expand each stage of this project, but would be happy to answer questions afterward. Ceramic material was collected from 2 sites along the Mopan River in the Cayo district. The Mopan River Valley is part of the larger Upper Belize River Valley, which was dotted with multiple sites in the early and Middle Preclassic periods. The interconnectivity of this region, created by its riverine system, influenced the ceramic distribution patterns, both shared and unique, that we see in the material record. The assemblages analyzed in this project are part of a broader east-west distribution of Middle Preclassic ceramics, predominantly orange wares across the region. I investigated ceramic materials from 2 sites in this valley: the Preclassic ceremonial center of Xunantunich, called Early Xunantunich, and the nearby settlement community of San Lorenzo. By analyzing material from contexts on two sociopolitical scales, I sought to offer a new perspective on the complex and interconnected relationships that existed between groups and ceramic producers in the Middle Preclassic Mopan River Valley. Ceramic material offers a robust record of economic processes like resource procurement and distribution. It also, however, lends itself well to the study of past political and social environments within which the material was created and used. The relationships between material, producer, and consumer are embedded into the clay body itself. Investigating these relationships, as this research ultimately strived to do, not only provides a more nuanced observation of the past, but also recenters the potter and the influences their social, political, and economic realities had on every stage of production. To test these relationships via the ceramic record, I analyzed quite large assemblages from Early Xunantunich and San Lorenzo at varying scales of intensity. Some level of macroscopic analysis or observation with the naked eye was performed on every sherd in both assemblages, totaling more than 4,600. I analyzed a number of different attributes for every sherd, but I want to highlight some of the characteristics that were most indicative of these markers of production. Again, I expected there to be an obvious difference between the sites here based on my model and hypothesis. However, many of the measurements were distributed fairly evenly. The assemblages from Early Xunantunich and San Lorenzo have very little variation between them. In truth, the only macroscopic measure that had real variability was paste texture. I measured paste texture based on grain size from very coarse to very fine, and the apparent firing environment based on the hardness of the paste. For example, very fine, high-fired individuals, like the one seen on the bottom right of the screen, were very well sorted with almost no visible inclusions. The pastes were hard to scratch, and the sherd made a distinct clinking sound when tapped on the table. Importantly, these very fine, almost vitrified pastes were found almost exclusively at Early Xunantunich, while San Lorenzo contained more coarse-grained wares with a tendency towards softer fine wares. In general, macroscopic analysis has revealed a few important characteristics of these assemblages. First, there's less discernible difference across the assemblages than I expected given my hypothesis. In fact, both assemblages measure up to broader regional trends for type and form during the early Middle Preclassic period. It's in the paste and decorative decisions that these assemblages stand out not only from regional trends, but distinguish themselves from each other. A further significant finding of the macroscopic phase of analysis is the definition of a new type in the Middle Preclassic Mopan River Valley. Magana gray, which I named after potters David and Estrella Magana, is defined by gray surface treatment, usually in the form of a wash or thin slip and high-fired paste. Where surfaces are eroded, the characteristic red or red-orange paste is visible. Almost all examples are high-fired, potentially pointing to paste vitrification and type-specific paste recipes. Decoration is limited to geometric incising on vessel exteriors, both pre- and post-slip, with a few examples of post-fire incising. Magana gray is likely related to the Mars orange ware so prominent across the upper Belize River Valley. In form and decoration, Magana gray would fit squarely within Mars orange as a new variety of savanna or reforma. However, the gray surface treatment is too consistent to simply be considered fire-clouded Mars orange, especially as fire-clouded Mars orange examples exist in these assemblages. Close comparanda to Magana gray was encountered at Calpech, described by Peniche Mai as unnamed black ceramic. However, distinctions in decorative technique and design delineate the types from each other. Chemical signatures produced through NAA further support the production of this type in the Mopan River Valley. Taken together, these characteristics suggest that the producers of Magana gray were following regional trends in form and decoration, but made different choices at critical stages of production, including surface treatment and firing regimen. After macroscopic analysis was completed, sherds were sorted by paste, including color, texture, and visible inclusions, so that a sample could be taken for the next phase of analysis. A total of 172 samples were chosen from these groups and exported for the production of thin sections. 4 additional samples of architectural daub were exported as well in order to create a control of locally available clay that likely underwent minimal to little processing before its use as daub in the Middle Preclassic. Thin section petrography was used to define ratios of clay to inclusions in the ceramic material, ratios that I then used to highlight potting units who favored specific ceramic recipes. Investigation of thin sections also provides important information about the production process. Some ingredients like specific minerals or culturally added temper tell us about resource procurement and the organization of production, while others like grog, clay mixing, and voids, which you see on the right, tell us about the actual clay preparation and vessel formation. To better visualize the distribution of inclusions within these samples, I conducted multiple statistical analyses on petrographic data. The one I want to focus on today is the ternary plot, which is shown on the left, and I'm happy to discuss other results in the future, however, if anyone has more specific questions. So on the left is the ternary plot, which visualizes the relationship between 3 variables, thus ternary, in a given sample. The one shown here assesses the ratio of quartzite, volcanic ash, and grog in all sherds tested. Using different mineral variables on the 3 axes changes the spatial distribution or spatial relationship between the samples and really highlights the effects that specific inclusions have on the way samples relate to each other, like statistically. I built a lot of ternary plots for my dissertation, and all the plots that included volcanic ash on one of the axes distributed in incredibly similar ways. So note here how the distribution of samples lines up by site on the volcanic axis. While most samples have a relatively high proportion of quartzite, it's the volcanic axis that gives us the most informative relationship. And it's important to note here that the more natural samples, so architectural daub and locally available clays, contain no volcanic material. So this indicates that this inclusion type is not found in the immediate surrounding raw materials. The final phase of analysis tested the chemical signatures of sherds using a technique called Neutron Activation Analysis, or NAA. NAA, prepared by Dr. Goodwin at the University of Missouri Research Reactor, resulted in 5 distinct chemical signature clusters, with a few unassigned and outlying individuals. The distribution of groups is very exciting to both me and the group at MR, as you can see in the biplot, the graph on the left, as well as the table to the right. Groups are delineated by site and type. Daub from both sites form its own group. Groups A and B are most intriguing. Here we see an absolute delineation of Mars orange wares by site. As noted by Dr. Goodwin, this is not only rare in the upper Belize River Valley, but rare between 2 sites so geographically close to each other, sites that likely had similar raw materials nearby, as evidenced by like-grouped daub. The sherds in these assemblages follow regional trends in form and surface treatment, which I found through the macroscopic analysis, and likely use the same iron-rich clays, again, that note towards the daub group, but it's in the paste recipe, those added inclusions, that these sherds differ enough to be delineated. This means that potters responsible for the vessels at each site had their own preferred recipes and were not sharing those recipes across the Mopan River. I initially hypothesized that Early Xunantunich's relationship with San Lorenzo would be reflected clearly in the ceramic record. However, through formal typological, mineralogical, and chemical examination of both assemblages, I discovered the relationship between the sites entailed a more nuanced configuration. While Early Xunantunich and San Lorenzo were both supplied by site-specific producers, there was no evidence of San Lorenzo pottery at the site center. According to multiple lines of evidence, as I've explained here, the markers of production in both assemblages relate in the following ways. So you can follow along on the chart as I read these out. The Variability of paste groups and paste recipes is slightly higher at Early Xunantunich, likely owing to evidence of regional and interregional exchange. The elaboration of surface treatments and decoration are equal at both sites, with a small portion of both assemblages containing complex motifs. And finally, there were no overlapping chemical signatures between Early Xunantunich and San Lorenzo. These correlates could suggest one of two possibilities. Either the relationship between the two sites was not materialized in the ceramic record, or San Lorenzo did not participate in the intercommunity activities represented at Early Xunantunich. The ceramic record at San Lorenzo does, however, indicate the site-specific production of fineware serving vessels, some elaborated with symbolic motifs of the kind likely used in intracommunity or local ritual practices. Over the course of this project, I analyzed a series of ceramic variables to test a model of ceramic production and its potential relationship to intra and intercommunity ritual practices during the socially and politically dynamic Middle Preclassic period. Without physical loci of production in the region like kilns, the model tests markers of production, paste, form, surface treatment, and firing to reconstruct the organization of production and the decisions potters made throughout. Decisions that were influenced by and embedded with the surrounding sociopolitical, ideological, and economic domains in which they were made. Using a multi-stage integrated methodology, I confirmed that Early Xunantunich was a node of intercommunity and indeed interregional network that likely gathered at the monumental site for activities like feasting and the construction of the astrological complex. However, it also revealed that rather than participants in intercommunity activities at Early Xunantunich, residents of San Lorenzo likely performed complex intracommunity rituals at home, supplied by hyper-local community potters. These findings should lead us to reconsider assumptions about the relationship between monumental sites and surrounding hinterland communities in the Middle Preclassic that are often based on a single marker of sociopolitical or economic scaling, such as monumental constructions. And with that, I would like to thank again the organizers at HENB for this wonderful symposium, as well as my committee members, friends and family, colleagues in multiple countries and funding agencies who made this work possible. Thank you.